Day. It represents the outcome of an intensive journey of innovation, collaboration, and strategic growth. Over the past 6 months, within the scope of the NATO program, a group of highly promising startups has engaged closely with the Turkish defense innovation ecosystem with the efforts of ODTÜ Teknokent. Throughout this period, they have built strong connections, refined their technologies, and strengthened their value propositions. To officially open the session, please welcome to the General Manager of ODTÜ Teknokent, Mr. Serdar Alemdar.
Hello, dear distinguished guests, dear ODTÜ Teknokent's NATO Diana cohort, investors, values partners. Welcome to our demo day here in Saha Expo 2026. NATO Diana program, as ODTÜ Teknokent, we are part of NATO Diana program for now more than 4 years. We are part of the process shaping the Diana program and bringing dual-use startups with the tech ecosystems and investors of the Turkish tech ecosystem. Today we will listen 8 incoming Diana startups and 1 surprise startup that's outgoing Turkish startup also will make a demo day for us, and their presentation and their pitch their solution to us, and we will value and experience shared experience with them and hopefully bring value to the ecosystem. So I want to just keep it short. Thank you for being part of this journey, all the startups. It's a long journey. For 6 months we were together in Ankara, in Istanbul, with the test centers. It's a very useful experience for us, and we are very eager to listen their proposals, their projects, and I wish all the presenting companies the very best in their journey. This is just a start for them, and we will accompany their journey together with them. Thank you for coming.
Thank you, Mr. Alemdar. Now, it's time to hear from the companies. Each company will have up to 10 minutes to present. Let us begin. First on stage, Elias Robotics, a Spain-based company developing cybersecurity AI solutions, enabling robots and autonomous systems to operate securely in increasingly complex environments. Please welcome Elias Robotics.
Thank you for the introduction. This is Sunaya Yukar from Elias Robotics. I'm the CTO of the company, and I'm here to present our solution here today. So why cybersecurity, why AI? It is not working. Now, awesome. Basically, this is a graph that shows how before cyber attacks were happening, and we have certain time to be able to defend ourselves. Years ago, a 0-day was a vulnerability that then could be exploited by anyone. It took more or less teams 2.3 years to be able to exploit that vulnerability. Nowadays, with the AI, it's less than 2 days. So if we don't use AI to counterattack AI, we are a bit in a hurry. Our solution is basically taking what every cybersecurity engineer use, a terminal. This is what everyone uses. If you want to scan a network, you use a terminal. If you want to create an exploit, you use a terminal. If you want to do anything, you just use a CLI. So basically, if we can connect this CLI, which is what everyone uses, to an LLM, what is the result? The result is basically that you provide access to your computer, antennas, Wi-Fi, anything. This can be deployed on premise. That means that can run in any robot, anywhere you can imagine. And what you provide is the brain, the LLM. something that can run in less than 10,000 euros of hardware. This means that you can go with a really powerful brain that has access to your whole system to be able to what? Do something that an agent defines. What is this agent behavior? It's basically create a new hack, evaluate a network, enter into a new Wi-Fi, do things that cybersecurity engineers do. Finally, the prompting of the user, exactly the action that you want it to do. Please hack that system, defend that computer, evaluate my network. This is our solution. Now, so this solution is based on 2 different agents, which is something that we configure ad hoc for everyone. Those agents is the pre-behavior that the system takes to act as we want. Why we are sort of the most specialized cybersecurity LLM in the world? Because we did our solution open source last year, and we were gathering data from everyone. We have information about the war in Ukraine. We have information about every part of the world. With that information, we crafted our own model, specialized for cybersecurity. And that is how we can perform our actions. Not only that, we distilled the model. That means that from a very big model, we went to a really small one. Why? Because I don't know you, but me, I'm bored of providing my data to the US, only to the US. I want to have my data myself. It's good to be part of OTAN, NATO, excuse me. And it's good to be collaborators, but the data that you are handling about cybersecurity should be in your premises. This is why we take a really big model and make it small, so that everyone can run it on premise. Our proposal in Diana was, now that we are able to run it on premise, let's take it to the real environment, where we can have adversarial opponents, where we want to have critical information. And we demonstrated this in the Locked Shields event. This is a NATO OPEX that happened 2 weeks ago, in which a company is simulated. This is the biggest cybersecurity OPEX in the world. Our solution was part of Team 8, the Spanish team. They were defending everything with our solution. And this is a video that if anyone can just put in to show how the solution works. The solution is as easy as select the model, which is going to go now. Model, alias 2, the one that runs into your company. Now we have connected our computer to the brain. What should we do now? Select an agent. How we are going to act? We have a lot of agents, all kinds of behaviors, defending, attacking, whatever. Just imagine that we want to evaluate a file. A reverse engineering could do that work. So let's select a reverse engineering specialist, someone that will analyze documents. We select the agent, and now the LLM will act as that agent. We'll know how to act. From there, which is the file that we are going to evaluate? What do we want to evaluate? That's what the user prompts. Hey, I want to evaluate exactly this image that says here, Kai demo reverse test image.png. How does that image look like? A easy image, normal one. Everyone has one of those. But in this case, has malware inside. So what we do is show that we are analyzing a normal image, whatever. This can be a network, this can be whatever, and see what our solution does. It starts looping different commands. It knows what to do. No user action. It gets the response from the terminal to execute the next command. And this way, you get information that there is a PE executable inside. That means that when it is launched into a Windows system, it creates a remote control of the computer. This is Alias Robotics, and this is Sky, our solution. Thank you, everyone, for your time and your patience. Questions? Allowed? Anyone? Just a question I heard. Yes. There we go.
Thank you for presentation. I have a question. Did somebody breach your security in that NATO event? Your team managed to, defend everybody? How was it?
So the idea with our solution in that event was basically to be able to provide logistic interaction. Our solution can create reports, for instance, for the intelligence that it was happening between the legal team and the intelligence team inside the NATO operation. Also defended the AWS machine that was into the scenario. It was creating a virtual country. And in that country, it was an AWS server that we were defending. Also, when new alerts were happening, they were passing those alerts to us, and we were processing those alerts to see what was coming on. Basically, it was our first year. It's the first time that we operated there. They said that we weren't going to collaborate too much, and we ended up in all teams. This is because AI can be used for anything if you know how to lead it. And what we provided is access to a computer to be able to be super smart.
Muchas gracias, Robotics. Thank you so much. Next, WizGuard, a UK-based company offering a hybrid AI-powered solution for advanced surveillance and threat detection. Please welcome WizGuard. Here's the microphone.
Good afternoon, everyone. My name is Alex Keogh. I'm the CEO and founder of WizGuard. We make visual AI to try and automate the cameras that protect us. Whether that's a drone, counter-drone system, or badass-looking USV, we've got some software that plugs into your systems to try and help you find threats. A little bit about me. So I've been, believe it or not, in the defense security system, industry for 21 years. Previously Royal Navy working on submarines, and then I worked for Hensoldt, which was a German defense company. So I got to travel around the world and speak to lots of end users about some of the challenges they were finding. And effectively, everyone was wanting their systems to be fully automated. So WizGuard's been going for about 5 years. We are a team of about 20 people, specialists in distributed AI systems and platform control. And we have, when we make the software to try and automate everyone else's defense and security camera systems, and we have customers from including people like the UK MOD, US military, various NATO partners, lots of defense tech startups, and also various UK police departments. So why do we have WizGuard in the first place? So from speaking to all those end users, they were saying that they wanted the additional automation, that they were missing threats. There's just too much visual sensor data for them to be able to try and tackle. And that's only increasing. So there's more and more drones, there's cameras are proliferating, and so we really need to try and help them out. So if you figure, oh, let's just add some AI to it, then it's very easy to get AI to work in the real world. But then as soon as you actually do deploy it, there's lots of challenges around actually getting it to work. And that data also, you don't necessarily want to be streaming it all the time. So there's a security element. But if you don't augment your users, then we're just not going to be able to tackle the latest adversarial threats. So we do need to really help them out. So at WizGuard, we've got two main products, and those combine together to make a hybrid solution. So we have Fortify, first of all, which is our camera automation software. That is TRL9, so it's already deployed around the world, and that will plug into your existing system. So we make it as easy as possible for you to integrate. It will control the cameras, control the drones, control the USVs, and it'll fuse with other sensors as well. So that's trying to provide you time-critical information as quickly as possible. Then we have Unify, which will take that data and try and improve it as quickly as possible. So the data stays at the edge, improves the models. So even if you're not using our AI, you can use Unify to improve your models in a day rather than weeks. Here's a bit of a conceptual kind of video around it. So it might start in a minute. There you go. So we've got some pan and tilt cameras. We're automating those. We've detected a drone. We've launched a drone to intercept it. We found out it's a nice friendly one, so we're going to let it go. And then we have an enemy car that's come in. So now we're tracking that. And now we've got the drone following the car. So those are all getting coordinated together with onboard AI. But then it also scales as well. So if you have a CCTV system, you can have potentially thousands of AI systems enabled by us and finding threats. So that's a lot of sensor data. And so how do you improve that and prove that it's getting better? So we have Unify, which is collecting all that data in. It's analyzing it. And with as little data as possible, it's trying to improve that model. And then because it's all software defined and because we're at the edge as well, we're also making this all work on GPS-denied navigation as well. So new features can be added as easily as that. And then we deploy the models. So that's all happening pretty much automatically. And it means that your systems are getting better in the field without having to send anything via the internet. So the applications include things like unmanned system automation, so typically drones, but also things like USVs as well. We've also had an unmanned submarine and unmanned ground vehicles. Border security, so either coastal or like perimeters, things like that, so automating the cameras, taking in radar footage and things like that. Counter-drone's a big one, whether that's on the ground, looking up, or on the drones themselves, so being able to steer these drones to try and hit other drones. Lots of police using us for that use case. And then public safety as well, so things like knife crime, even things like suicide prevention as well, trying to provide the earliest indication when someone might try and jump off somewhere like a bridge. Our customers include medium to large defense and security companies, people who have solutions or they have drones and things like that. They may even have their own internal AI, but they realize that's not something they specialize in, and then they kind of bring us in. Most of our customers, in fact, have tried to use AI, but then they outsource it to us in the end. And we think we can help customers get to market 50 times faster than if they attempted to try and build the same kind of solution in-house. And there's an image there from a NATO OPEX, a steadfast start, where we're working with our partner Parrot with the onboard AI there, and then being able to detect and evade other drones as well. So we're seeking anyone who would like to try and help their operators out, to try to reduce the burden on the operators, to try and find threats faster. If you already have AI and you think, oh, Alex, I don't care about your AI, we've got some amazing AI, then consider Unify, so that actually can help you improve your models. Everyone's using things like YOLO, so open source models, so we can help you make those much better. And then also this year, we're hoping to raise some more funds as well, so hoping to raise £5 million. So if there's any investors in the house who'd like to talk about that, then come over and see. And that concludes my presentations. Happy to answer any questions. Oh, there's one question.
Okay, thank you for your presentation. I'm Colin Ayhan. I just want to ask for the capacity of the system. So what's the capacity of the system to distinguish the items threat or not threat? For example, in a crowded city like Istanbul, how can distinguish the items?
Items or threats in general?
Yeah.
Yeah. So typically, an AI system, what you've seen many times, will put a box around something. That's not too useful if it just says, here's a person with a box. So what we do is we try and go into much more granular information about that particular thing. So we'll say there's a person, there's a location, they're armed, they're coming out of this colored vehicle and things like that. And each person or vehicle or vessel is given a threat rating from 0 to 100%. And then there are certain thresholds that eventually get alerted if we believe there is a threat there. So we're trying to provide that kind of threat prioritization, and then we're automating the cameras to kind of follow them so the operator doesn't have to be really skilled at trying to follow them. So there's various different ways in which we can try and distinguish if someone is a threat or not.
So does the capacity or is limited or not limited for the distinguished items?
The capacity.
So we have a capacity, yeah. So in a crowded city, you can distinguish all the items in 1 hour, for example.
So we've got a few different models for detecting different things. If you had a particular thing you wanted to detect, then you can train the model using our software, and you can run the models within it. So if there's something in particular you'd like to be able to detect, then we can create custom models for that and then run it. And we can also run multiple models at the same time to try and get more detail.
Thank you.
Thank you very much.
Thank you so much. Each time we can take just one question. Thank you so much, Vizgard. Up next, Neural Agent, a Germany-based startup working on autonomous swarm intelligence enabling coordinated and adaptive multi-agent systems. Please welcome Neural Agents.
So thank you very much. Today I'm here to provide you a technology telling we are better than the market or existing all AI systems, helping you to solve defense problems. We are focusing on technological sovereignty and resiliency in defense and space. So our aim is to give you the control of your networks and unmanned systems, not an AI solution 10%, 20% better than all the existing defense systems. The global technological challenges that we have starts with the networks. So if you don't have your network, if you cannot control your network, your unmanned systems, billions of dollars of configurations are useless. That's not going to bring you success. As we have seen in Ukraine, when you need a successful operation, then you need to ask somebody else to provide networks. So that's why there's a huge sovereignty risk in your operation in order to solve your problems. On the other hand, interoperability is one of the biggest bottleneck in the battlefield. Your different systems, heterogeneous systems, cannot cooperate. They don't have the capability to collaborate in dynamic missions and act and take decisions. On the other hand, end-to-end latency. So decision latency and network latency should be combined. So at Neurolegend, we solve this problem and we fill this gap as in the interoperability by turning these fragmented complex networks into self-organizing systems. You see an illustration here that satellites, moving drones, and ground systems and underground systems. So network is not just a single drone, it's not just a single satellite. You need to have the ecosystem, and if you have access and control over those systems, then you have unfair advantage. And this is what we provide for the NATO nations. Our solution provides benefits such as undisrupted missions, that it has the self-healing resilient networks, just like ant colonies. When something is attacked, they have the capability to reconfigure themselves on the edge. Multi-domain interoperability, the agents, the solution, the operating system is totally compliant and contributing to NATO Standard 4817. And reduce decision latency, so cloud freeness. So you don't need to connect to cloud to control your systems. A cloud cannot orchestrate hundreds of thousands of systems at the same time. It's not feasible. It's fully decentralized orchestration layer, what we are building here. Our product landscape starts with the space, which is called Orbinet, which orchestrates the space satellite networks and to get you space situational awareness and orchestrate your networks. And in the air and defense systems, we have Skyguard. We developed Skyguard to bring the fully decentralized execution and centralized control for the army, for the military, for the governments, to fully have network control and unmanned system coordination. And the Skyguard is leveraging the Q compression algorithm. Is one of the most capable algorithm that reduces the video stream from 50 megabits to 2 kilobits per second, so that you are always connected. Skyguard has been further developed in the NATO Diana program and brings you the ability to chat with your drones in real time without using LLMs. Everything happens in the edge. You talk with them, they talk each other, and solve the problems under heavy jammed and GNSS denied environment. And this C2, as soon as you define your tasks for your drones, everything is executed autonomously, which is combined with the visuals, which we have some battlefield confirmation that our recognition system works on a very complex environment, and the system, the swarm, has the capability to adapt itself on a very dynamic condition, and you have the fully control of our unmanned system and human in the loop all the time. And today we will show you how the system operates in real time. And we would like to also invite you to our booth that you can test, see on our physical demonstrators. And I give the stage to our chief engineer, who's going to explain you about the agents and their use case.
Thank you, Honor. I am Nugroho Ferdivianus, Chief Engineer at Neurolegend. I have 15 plus years of experience in agent and swarm engineering. So basically what we are doing right now, what we are offering you, first we can see that we have autonomous agents. They are lightweight, no GPU required. We can put it anywhere, on the satellite, on a small drone, Raspberry Pi, even your smartphone. It's possible. It's explainable, intelligence. So you can basically see what the agent already learned. What is the knowledge? What is the situation? What's the state? How it resolves something. Updatable on the fly. So if we have satellite, we cannot really bring it down to the earth, put another intelligence, and then put it back up. We have to update it like from the earth to the space. So that's why also with the drones, also with any kinds of agents that we have, and also scalable, cloud-free, and it's designed specifically for standalone edge devices. And the human-machine teaming, first we have natural language. So you, at our booth, you can see we can command the drones, the swarm, with your natural language. We have like Turkish language, we have English, of course, we have German, we have Ukrainian, Arabic, and yeah, not almost all, but yeah, many languages support it. And this is what's been the difference from the others. One pilot controls the whole swarm. You have 100 drones, no problem. One pilot can control them. The swarm will orchestrate, reorganize themselves, and they will know what to do. For instance, if we give command 5 drones, go to this point, make a surveillance, they will decide who is the 5 drones. And all of those kind of things that we don't have to really think a lot, like engineer a lot, It's just with the lateral language commands. Yeah. And the video. Yes, so this is the video. You see on the left-hand side is map. So because this is swarm, this is the probably the most representative of the swarm. We see here 12 drones. And then here's the swarm in real time. This is physics engine. This is not simulation, not normal simulation. This is the last phase before hardware. So basically when I switch a bit, then this becomes the real drone at once. So that's why we are not doing visuals here. We're doing this exactly what it appears. And there's the prompt. So you can say in this visual, like follow agent 1, follow drone 2, follow drone 3, go up 15 meters and so on. And yeah, the result, you can see these drones here and also the swarm at some time. And yes, for instance, there's a formation, circle. So build a circle in, meaning it's heading or the facing inwards. So as you see here, it's probably not too clear from your side, but the drone is facing inside. And we can also do another formation like turn back. When we give a command like turn back, the drones, all of them will turn back. So they now facing outward. And this is just a very simple formation that we can show you. There's a lot of formation. We will also show you the wedge formation, sweeper formation, and so on. And go, meaning go out. You can see now the drone is going out right now. This is actually also the representation of part of the swarm. And now formation wedge. So it's basically an arrow without the middle line. And as you will see, when we give it copy, forming wedge, and then they build automatically this form of wedge. So in this case, imagine if you have 100 drones, you can ask 10 drones form wedge. So the 90s just stay still, and the other can directly form what we really want to surveillance and everything. And yes, you see here, there's a chat. It's actually not visible. There's a chat between us, between the user and also the drones. There's also the window to see. You can see at our booth, the chat between the swarms in any language that you want. So because it's explainable, we can explain it in any language that we really want. Now the command is formation sweeper. And what we have here, this is the formation sweeper, so like one drone in front leading, and the rest is just making a line behind it. And as we see here, the formation will then, I ask him to turn back, the agent 1, the leader, so turn back, so the other will follow. So it's turning back, as you see here, this is agent 1, it's turning back, and then it will go south, and the rest will follow. And as you can see here, yeah, so this is very easy, very simple. Anyone with some basic known of a language can do this. And we don't do this using LLMs. We use a very specified parser. We use a very specified translator using that is intended to do it in the edge devices. Yes, for instance, the mission patrol. We ask them, okay, 5 of you do some patrolling near the base, and as you will see, when the mission is given, it's responding, and then it delegates to 5 drones. 5 of them will do the patrol. So 5 of them will go south, and then the patrolling. This is the base, the starting point of their operation. So while the 5 of them doing patrols, so what is the rest doing? So it's just staying there. So we ask them to, so for the 5 of them is circling, patrolling is circling, and then the rest of them, we will ask them to do surveillance. So we basically ask them to build a relay from the base to the surveillance point, whereas all the others are circling the surveillance points. And we can do this just with one prompt. Basically in any language that you want. We haven't, as I said, we haven't installed all languages, but if you want, you can test Turkish, you can test Arabic, you can test, I don't know, Romanian, I think there. Yeah, German, definitely. French, Spanish, yeah. So this is what they're doing now. They're doing survey. You want to?
Thank you very much. So you haven't seen any LLMs at all. It was full edge AI on physical systems collaborating in real-time missions. And in June, we are looking forward to show you with one of our drone manufacturers in real time how they detect an object and collaborate together and neutralize it. I'm looking very forward to your questions.
Yes, do we have any question? Okay, everything is just clear. Dankeschön. Next, Hydrogen in Motion, a Canada-based company developing modular hydrogen energy systems for clean and efficient mobility solutions. Please welcome Hydrogen in Motion.
Thank you. The need for energy and the demand for it is on the rise. We never need less energy. But getting it to where you need it has always been a challenge. And you see that even especially in defense. There's been a report by the US Army released in February this year that electricity has become the most critical enabling commodity in ground combat. And without power, the Army cannot sense, shoot, communicate, or defend. And you can see a platoon requires 5 to 7 kilowatt hours a day, and a company requires 14 to 21 kilowatt hours a day. So what are the current solutions available right now? As you know, batteries are a fire hazard, and lithium is a geopolitical risk. With diesel, the gensets are hot, they're noisy, and they produce smoke. So there are targets as well as the supply chain itself. The hydrogen motion solution is a compact, portable energy generation system that we have on the front line. And you can, if one gets destroyed, you'll have still a grid mesh network with resilient power. So what is the hydrogen motion solution?
Power is essential, but getting
Oh,
energy
the
to the right
sound's not
place
on.
at the
Sorry,
right
we'll
time
have to read it.
is harder than it should be. Today's options all come with trade-offs. Batteries are heavy and don't last long. Fuel is complex to transport, difficult to store, and adds logistical risk. And as operations become more mobile and more distributed, those limitations become even more obvious. Modern missions need clean, renewable power that can go further, last longer, and deploy anywhere, without being tied to infrastructure. That's where hydrogen in motion comes in. H2M has developed a solid-state nanomaterial that changes how energy, in the form of hydrogen, is stored and moved. Instead of handling energy like a volatile fuel, it can be managed more like cargo. Safer, more flexible, and easier to scale. Energy can also be decentralized and generated on-site. This unlocks longer range and longer duration capabilities across a wide range of applications. Drones can fly longer and redeploy faster. Remote or off-grid locations can be powered reliably. Portable power packs enable mobile energy for equipment and operations. And, at larger scales, energy can be transported using standard shipping containers filled with H2M material, allowing energy to move through existing logistics networks. From small devices to containerized systems, everything uses the same underlying material. Power becomes clean, zero emission, modular, scalable, and deployable on demand. The result? Simpler logistics, improved safety, and extended operational reach. Because clean energy shouldn't slow you down. It should move with you. This is hydrogen in motion.
Thank you. So for NATO, we have deployed it in NATO Diana Phase 1 is a high-altitude UAV with our swappable tanks. Gives twice the range as a battery-powered UAV. The second phase will be the mobile hydrogen and energy generation. From this unit, you can, using solar power, you can get hydrogen, water, potable water, and electricity. A deeper dive into our technology, what makes it so extraordinary? It's a carbon-based backbone that absorbs hydrogen under low pressure. Unlike high-pressure tanks at 700 bar, we operate at 50 bar, so 90% less power. And as well, it's not, it operates at ambient, not like liquid hydrogen, which is minus 253 degrees Celsius. So our material is non-toxic. It is no rare earths, and these units can be recycled and reused thousands of times. So in essence, we make a smaller, safer, cheaper tank. I would like to tell a little bit of story about myself, why I founded this company. In 1997, I said the next car I'm going to buy would be a Jaguar with a Ballard fuel cell in it. They didn't exist then. They don't exist now. So in 2012, I was on Mount Kilimanjaro. That's me at the summit. And I said, I think I need to get involved with this technology because what's holding it back? And what's holding it back is energy, hydrogen storage. So I got together with my co-founder, Mr. Mark Cannon here, and we put together a team of hydrogen storage experts to make this specific nano material. Material science is always what changes the world. We didn't leave the Stone Ages because we ran out of stones, right? So before I founded this company, I used to work for the Treasury Board Secretariat of Canada. We managed Canada's $250 billion budget. And managing large money, it told me money flows where risks are mitigated. And where our strategy is a staged approach with military, with NATO Diana, Canadian D&D, our marine pilot with C-SPAN and the Ocean Supercluster. We have 2 land pilots and a commercialization feed study. So my last slide here is moving back into the first slide of how we can service the energy battlefield. Hydrogen Motion, this portable system, our infrastructure independent energy, provides 33 kilowatts of power. And that will be more than enough to power a company. If you want to talk to us about it, we're seeking people who are looking to demonstrate, and we can talk about how we can fit this into your needs. We are in section 305. Thank you. Any questions?
Thank you, Hydrogen in Motion. Thank you. Up next, Eric Systems, a France-based company proposing compact, high-precision and autonomous propulsion solutions. Please welcome Eric Systems.
So hi everyone, I'm Hugo Malinov, co-founder and president of Eric Systems, and today I will introduce you the next generation of drones. So to begin, my first purpose will be, if you are looking for, you are in a trade show, if you're looking around, all the multi-rotors are quite the same. And today, if you're looking to them, they are primary architecture and they haven't been reinvented since the beginning. We have seen some drones. And basically, you still have the same physical limits and you will have always the same business limits because you have one drone for one purpose, for one use cases. So to tackle my first purpose, it is to propose, thanks to our robotic past, to say, we need to reinvent the propulsion systems, the essence of the drone, in order to increase our aerial capabilities for plenty of applications. So this is fully unique. We are the only one in the world doing this type of propulsion systems and the autopilot inside. To tackle my second purpose about the business model, you saw too many drone makers creating a drone for an application. So the idea for me, for my company, is more to provide an OEM approach on our differentiator and also to be able to provide an agnostic platform in terms of mission and in terms of integration. And in less than 1 week, you are able to dedicate a C2, a AI, a data link, and also the payload. It's very easy to integrate and non-intrusive for the end users. So to be clear, it's not a full perfect solution. It's a compromise, engineering compromise. If you want to carry some payloads, multi-rotors are the best. If you want to go fast, rocket design is the best. If you want to go far, fixed wing are the best. But if you want the best world between all of these systems and the best terminal accuracy, the best stability, the best maneuverability, we have designed this omnidirectional propulsion system drone. We are a dual company, but we are a member of Diana, and we have developed a lot of use cases around defense. And our proposition for Diana and NATO was mainly on the counter-US, and specifically counter-FPV systems, where we were the second company in the world able to catch a target in hit-to-kill approach. You don't need any ammunition inside. Just with a reinforced head, you are able to catch an FPV drone, just go on the fuse and declench and destroy it. We are also working for loitering munition in a more cruise missile approach, where terminal accuracy and angular accuracy allow you to settle new type of military weapons. We are also working for target designations as a decoy, flying decoy, and you are able to aim with a gun if you want. And we have some specific topics on radar hunting. Oh. Not working. Okay. So please, to introduce our what we have done for Diana, we were working on counter-US and counter-FPV, so you can see at your right the targets. And so we send a C2 designation, the coordinate of the target, refreshed every hertz, and we are able to catch it directly and do an hit-to-kill interception. So it was in a fully autonomous way. You still have a human in the loop, but it behaves like a fire and forget system. So, okay. So as I told you, we are a dual company. We are mainly focused also on counter-US, but more in a softer way in order to protect airport, civilian facilities. We are also working for inspection and also as a drone able to clean some things. So just to introduce what we are doing currently in France for nuclear fields. No. So we are currently working for inspecting in contact, in continuous. The idea is to inspect critical infrastructure in contact. It's quite hard to behave like a flying robot in this way in order to check and have in-house efficiency, in-house precision. And in this way, if you want to have 1 millimeter precision, you just add some wheels to the systems in order to inspect in 360 degrees in any direction. Please, next slide. So yeah, today we have 3 products off the shelf. It's 3 platforms. It's like classical drone. More you want some payloads, more you want some capabilities, you just need to increase the size. But it is fully off the shelf today. So now we are currently developing a new ones because, as I told you, my previous system was able to catch tier 1 NATO class threats. Now we are more and more addressing higher threats, tier 2 and tier 3, like helicopters, for example, so you need more speed. And in this way, this is the first in the world omnidirectional, I would say, thrust vectoring rocket design drones. And in this way, you are able to catch directly and be more efficient. You don't need proximity fuse, just go with an hit-to-kill approach. And it can be also for counter-UAS, but also as a loitering munition system. So just to sum up what we have done, we have recently raised some funds, 5 million euros, in order to accelerate on the defense market. We are fully supported by European Defense Agency, by French MOD, and also now by NATO. And more we are increasing manufacturing capabilities in order to address all our demand on different topics. As I told you, we are kind of robots, in fact, manufacturers. And we are more and more going on the expansion of the range, the certification, and more going on a strategic partnership in order to provide some specific end-to-end solution. And now we need a new fundraising, about 15 million, in order to decline the propulsion system for other environments, such as underwater or even space. So, okay, thank you so much. Maybe just, yeah. If you want to discuss, please feel free to send me an email or to discuss just after the meeting. Thank you so much.
Merci beaucoup. Do you want to ask some question? No. Merci beaucoup. Yes. Next, Arke Telecom, a Turkey-based company specializing in advanced communication technologies, focusing on secure and resilient telecom infrastructures for critical applications. Please welcome Arke Telecom.
Welcome. Barış Karadeniz. I am CTO of the company. Today I am going to present you Arkelink, a resilient communication architecture specifically designed for tactical drone operations. We are an 11-member engineering team led by senior engineers, including myself. Each of us has more than 25 years of experience in defense sector. Our expertise is in military communications. We handpicked our team from top Turkish universities. They are young, talented, and highly focused on military waveform development. We are Aselsan approved supplier. We have NATO cleared development and testing facilities. We hold ADP certificate, which is very important in Turkish defense ecosystem. We are the only Turkish company accepted to Advanced Communication Technologies Challenge. We are not actually a startup company. This is not our first waveform project. We successfully delivered many waveform development projects for Aselsan. Frankly speaking, some of them are much more complicated than Arkelink. These are the projects we delivered in the last 5 years. Total value of these projects are approximately $3.3 million. So now we are developing Arkelink. This is the first waveform we are developing under our own band. Recent conflicts in Ukraine and Iran undeniably showed us that the future of the battlefield is in unmanned systems, specifically drones. But the military communication systems couldn't meet the communication needs of these drones. So the operators start using commercial products, but those commercial products failed because they rely on GPS and they are easily jammed because they are not suitable for the battlefield. So what kind of workarounds are there? One of is FPV drones. They are short-ranged, and also fiber optic cables are being used in Ukraine heavily. Fiber optic cables provide resilience against the jammers, but they limit the operational flexibility. They expose the position of the operator, and the most important thing is you can only control your drone with the fiber optic cable. You cannot communicate between drones using fiber optic cables. So here the main bottleneck is the wireless communication link. And we are going to solve that problem with our Arkelink waveform and software-defined radio. Arkelink is a GNSS independent waveform. We not only don't care about the GPS signals being jammed, but we also provide our own positioning, navigation, and timing service to the end user. This service is a built-in feature embedded to the Arkelink waveform. We also provide fast frequency hopping in a wide bandwidth, and also we provide micronet capability. Micronet capability is like this. Any pair of drones at any given time are communicating with each other at different frequencies. They use different frequency patterns. They do not interfere with each other. This highly increases the total throughput of the network. And also it's very hard for the jammers to jam the system, because at any given time, more than one frequency is being used. And also self-healing mesh architecture. We provide multi-op, multi-node communications. We are not an AI company, but as you see from the previous presentations, the future is in AI-operated drone swarms. Arkelink will make it much more easier for AI-operated drones to communicate each other. Arkelink is a very complex waveform, so we already developed a complex digital twin and simulation and emulation framework just to develop Arkelink and verify it. As you can see, drones are moving freely, new links are being formed, some links are lost. This is not an animated video. This is actual recording from our simulation software. Each of these drones represent an Arkelink node. Each one of these nodes are STR, and the same code that is going to run on the hardware runs here. So we can analyze our protocols, our transmissions, and we can analyze Arkelink waveform behavior for different topologies. This is the interface of ArkeSim. This is the main interface we use while developing waveform. We have lots of metrics like end-to-end packet delay, packet success rate. We run extensive tests. We provide lots of measurements, and so we can understand how the waveform going to behave in different topologies under different conditions. So we provide jamming resistance, mesh network, range extension. We have operational flexibility. In short, we are aiming to provide military-grade capabilities for a civilian price range. This is our 36 months of execution plan. We are now at TRL 4. We are aiming to reach TRL 5 before Diana phase 1. We are going to start integrating our prototypes to Turkish drone manufacturers in the following months. We are planning to manufacture prototypes at the start of next year, and after 24 months we are planning to mass product our STRs. We are also expanding our product family. We are going to develop Arkelite and Arkelong. Arkelite is a lightweight version of Arkelink for micro UAVs, and Arkelong will provide extended range for long-range operations. We are going to start developing these waveforms at the end of this year. We are also planning multi-domain expansion. We got lots of questions about for the ground and the surface vehicles. In the last 4 months, this project gained strong traction and attracted interest from various companies. We have signed memorandum of understandings with Turkish aerospace industries and SN Systems. These are the companies we are going to integrate our prototype in the following months, and we are going to make flight testings with them. Also, we secured 1.1 million euro funding from the ACT and ODTÜ 70, ACT being the lead investor here. We reached an agreement on term sheet last week, and now the due diligence is in progress. Thank you so much.
Arke Telekom, çok teşekkür ediyoruz.
Thank you very much, Arke Telecom.
Neuron Innovations, a technology company developing intelligent systems that enhance data-driven decision-making and operational efficiency in complex environments. Please welcome Neuron Innovation.
Good afternoon, everyone. My name is Neil Greenwood from Neuron, and I've got 25 years of defense and cybersecurity experience And one thing that tells me is in the military, you never have all the information you need at the time you need it. And this is becoming a harder and harder problem for operators to achieve mission success. If we look at current systems, they have a problem. They don't scale. They're dispersed and the information is fractured across many different centers. Integrations have to be made bespoke and they're very slow. And access and trust to those systems has to be manually handled. This means that commanders often have difficulty making decisions in real time. Coordination means giving over control, and you then have systems with single points of failure in them. So what critically happens is when you need the information most, you can't get it. We solve this problem by deploying agents on the edge across networks. They have standardized interfaces. We have verified identity and permissions, and they provide peer-to-peer connectivity between all network members. This allows discovery, trust, and coordination, so access across all organizations without giving up control and without any single points of failure, meaning that systems connect and can talk directly to one another. Why do we need to do this now? Because systems autonomously are proliferating more than ever before. We've all heard about swarm drones. This is a very good example. Systems are distributed across multiple organizations and agencies, and decisions now need to be made in real time because machines are making decisions in real time. And the current hierarchy of architecture can't support this approach. So this is what we design instead. Agents that sit on nodes on the network and communicate and interoperate automatically between each of those devices. We use the Mosaic project to do this, which is a multi-domain orchestration system for agentic interoperability and control. We also test this thoroughly to make sure it performs exactly as expected. So we build a test sheet, 2 specifications, requirements if you like. We build that test sheet. We test it. We verify the data that's delivered from it. And we output set software specifications, test reports, and evidence that it works in the way that it's supposed to. So I think we might need new control batteries. This isn't a concept. This is deployed in a live environment and proven now. We use it to coordinate drones in civil airspace in the United Kingdom, to manage that airspace, and to coordinate the sensors. We've moved into defense because defense has the biggest need, so this is a true proven dual-use case. And in the future, this will be a huge area for infrastructure, for smart manufacturing, for energy, disaster management, etc. So this is a live dual-use deployment. It's an ATC in a UK airport. You can see a field installation by the side of it. We have over 700 agents deployed worldwide. We're adding 200 a month. We're also taking revenues at the moment, so this is a system which pays operators to be part of the network, and it's trusted by the biggest names in defense and aerospace, and you'll see a few of them across the bottom there. And for the operators, this fundamentally changes how they do business. This airport manager used to control aircraft by looking out of the window of that tower, and now he can control everything that he needs to do on the screen of his common operating picture. What does it look like in practice? We have a drone flying a mission, maybe an intelligence mission, and we integrate with it the information from civil aviation aircraft. So they can see the aircraft with data markers, updating in real time. They can see the altitude of the aircraft, and they can conduct, for instance, a VisGuard mission safely separated from those civil aircraft. So this immediately allows us to detect and avoid other aircraft and operate in a commercial space, often at great range, further than we're looking with the camera at the moment. And you can see the aircraft flying overhead there, and so you can see that they're safely separated and operating in a safe manner. But we can add to this network. This is a 3D printed Arcani counter-UAS system. It's detected a drone at 400 meters with RF and acoustic, and then we can attach it to another Diana, ERIC system, for instance. You've seen this already. So there's a hostile drone. It could be a Russian drone over Turkey, and then we decide to intercept it, and the drone is taken out. It's an end-to-end kill chain of 4 different activities that previously couldn't communicate. By putting the agents on those devices, that data can be shared from device to device in real time and makes an end-to-end kill chain. The founding team have expertise in autonomous systems, cyber, defense, and distributed infrastructure, and they come from the biggest organizations in the business. Why are we doing this now? Because every system needs to be able to interoperate, and NeuroMosaic provides that layer. Systems that interact directly, across organizational boundaries, and at scale. We're deploying the coordination layer across defense. We're seeking primes and integrators to partner with, OEMs for systems integration, and investors for scaling. You can scan my details there. Please come and visit us on the stand. We're here today, tomorrow, and on Saturday, and we would like to share more with you. Thank you very much. Any questions?
Is there any questions for Neuron Innovations? Thank you, Neuron Innovations. Next, a company focus on delivering cutting-edge engineering solutions with strong applications in defense and advanced technology sectors. Please now welcome Atlas Innovative Technologies.
Cool technologies there, yeah? I'm really glad being a part of that. It's an honor. I want to start saying something about jamming interception. Every tactical communication platform in use nowadays can be jammed, can be intercepted, or taken down. A dear friend of mine that's here today, that's really good, he was sharing a good story to me. He was deployed in Bosnia, and we are talking about 30, 40 years ago. He was responsible for communications, and they were communicating between groups, and a day before, they were selecting a certain frequency to keep these communication lines on. So it took one day to have a mismatch. They could talk, nobody could hear. For operational perspective, even though you have like a few hours without communication systems, that can be fatal. That happened around 40 years ago. We advanced in time, the same problem still happening. Not just because of a lack of communication or some mistakes. We're talking about jamming and interception threats. We can see that happening in modern conflicts. And we can see that nowadays, the environment of communications is like a crowded aircrafts. We have like vehicles, troops communicating with each other. It's a mess. We're talking about radio frequencies. Yes. But when happens jamming or interception, that can present many outcomes. Troops are being circled, people are getting killed, and I'm not talking just soldiers, civilians. Operations are being disrupted, and also expensive equipment that we can see, like many of them here, they're being destroyed or just becoming useless. And I was wondering what if we could deploy a capability that can bring these communication lines on, that's resilient, fast. Doesn't matter where it can be deployed, from open fields until top of the buildings. something that would take minutes. Well, I'm here today to tell that this capability exists, and its name is AracNet. AracNet is a fiber optics mesh network that's being deployed by drones. Don't worry, this is not a functional one, in the middle of the battlefield. And you're wondering how it works. The drones, they carry the nodes. As you can see, here we have two. These nodes, and everything is interconnected by fiber. Therefore, from permissive areas that we don't have jamming or interception threats, until denied environments, we can deliver this capability to the most vast environments, even under heavy jamming or interception threats. And I invite you to think. We have like certain aspects. How can we deploy this capability? Well, I can present 3 of them. Do you remember the troops being encircled? That happens a lot in Ukraine. Well, they're under heavy jamming or interception threats, but not anymore. We can reestablish communication link, fast, reliable, resilient, and we bring to them. No jamming sources. We don't use radio frequency. You may think, oh, maybe enemy forces can pinpoint our location and send barrage strike. Good luck with that. We don't use radio frequency to communicate. Therefore, the same troops now can hear, now they can talk, now they can advance, they know where the enemy forces are coming. It's a choice. But I want to move even forward. From the permissive zones, our dear operators, it's invaluable in a conflict nowadays. Pernicious areas, really safe, they can use the LOCC, and through our network, they can pilot drones right under jamming interception threats, maybe even behind enemy lines. They can pilot collecting ISR, intelligence, surveillance, reconnaissance, or use FPV drones to strike the enemies at their back. That's just 2 cases. I want to present one more. Imagine a drone operator in another country using our network. Yes, we can implement a SATCOM here. Let's say Starlink. They can use our network and the other part collect ISR in the same way, in a real time. But of course, we're not here to substitute the existing equipment. I know that they work really well. We're talking about many big corporations here, but we want to integrate our network with the existing solutions. We're working with several layers, physical, transport, supervision, and control. The total is 6. And if you may wonder, of course, the capabilities today, they're really great. I can see, especially with NATO Diana program, nice innovations. But we have our competitive advantages, of course. We're immune to jamming because we don't use radio frequency to communicate. It's stealth by the same reason. We offer full telemetry, high definition, because it's fiber optics. We can bring the system anywhere, from vast fields, as I told, until top of the buildings. It's unique. We own this technology. We are first. And we offer all of these things and much more because it's mission specific at a lower cost. So here it's an operational deployment, how it would work. From the LOCC, Local Operational Command Center, we can fly drones to specific locations where our troops are located. Every point that you can see the soldiers is a point of deployment of one node. In this example, we have 2, we can carry more. You may ask, oh, okay, you are laying fiber optics. What if the connection gets just cut? It gets rerouted. That's why it's a mesh network. And we are talking about 3.2 seconds to that to happen. It's a record time. Therefore, our soldiers can move, they increase their survivability, and also the most important, It's operational success with low casualties. And that's what communication does. That's what Atlas is focusing. Here are a few examples. We were doing some testing. This is the second version. We're in the fourth version here. So it's the fiber, the node, our AracNet drone with the what I call LOCC. That's the computer. The port of entry can be other equipment because we integrate. In the other one, it's the Starlink communications that we were making the testing. Yeah, so it seems that it got jammed. It's not fiber. Our objective is simple, is to make sure that communications, one of the most critical assets in the battlefield, it's never a point of failure. And I would invite you to scan the QR code. Let's talk, let's book a demo, and thank you very much. If you have any questions.
Thank you, Atlas Innovative Technologies. And finally, Similarge, another Turkey-based company optimizing manufacturing with shop floor validated physics-based digital twins for fast, flexible, and reliable performance. Welcome, Similarge.
Thank you very much. Dear all, welcome. I am co-founder and CEO of Similarge. I am Dr. Büryan Turan. At Similarge, we offer physics-informed artificial intelligence technology to improve efficiency and reliability in manufacturing lines. This is a huge problem. In manufacturing facilities, there is $8 trillion loss due to scrap and rework because of the trial and errors and manual operations and inefficient operations, because the decision makers are the operators operating manufacturing equipment in the shop floor. I am Dr. Büryan Turan, as I mentioned earlier. I have a great co-founder who is Dr. Erhan Turan. We both worked for General Electric Aerospace for many years. We have both of us have PhDs from mechanical engineering, and we are expert in modeling and simulation of machines. We designed aircraft engines in GE, and now we use our thermal systems design experience and software development capabilities that we acquired during our PhDs to help manufacturers, to help manufacturing lines to reduce costs and scraps. In GE, for example, we observed many losses. There were defects after manufacturing processes, and in order to deploy these defective parts, there are thousands of engineers analyzing these parts before their installation to the aircraft engines. But these defects should not occur, right? These cannot be occur in a critical environment, for example. In defense zone, in war zones, equipment should behave resiliently without any defects in order to perform better, in order to prevent malfunctioning. Because of that, and also there are a lot of scraps and engineering hours to analyze these parts before their deployment. Therefore, these defects should be prevented rather than inspected after the manufacturing process. And let's assume that they are deployed in an equipment. For example, in Antares situation, there was an explosion during takeoff because of a manufacturing defect. Therefore, it has a crucial impact not only on a financial perspective, but also for security perspective. From another commercial aspect, for example, in automotive industry, there is defect in batteries, in Renault, for example, and they recalled their cars, and this was a huge impact to their business. In Ukraine war, there are some specific examples in NATO reports. There are malfunctioning equipments, early explosion of ammunitions due to defective manufacturing of the parts deployed in the equipment in the manufacturing field, the war zone, in the operation field. And NATO's ACT and ASAP initiative says that manufacturing processes should be standardized and digitalized in order to prevent such issues. As Simularch, we offer a physics-based artificial intelligence technology to prevent these losses. We offer a plug-and-play mini server. It comes with our built-in software technology. It connects to the production line. It starts to get data from sensors. It makes calculations and gives recommendations about how to operate these manufacturing machines in order to prevent them to produce defective parts. We prevent it. We doesn't inspect it afterwards. We prevent these defects. Our technology is a patented one, and it has more than 95% accuracy in prediction, and it's 10x faster compared to our competitors. Our technology not only models the manufacturing equipment, in this case it's an industrial oven, for example, we also obtain the digital twin of the part being produced inside the oven. So our technology is a 3D simulation, real-time simulation, coupled with sensor data, so it can give us insights about what sensors cannot measure. For example, a thermal camera can measure the temperature distribution on the part, but cannot measure the temperature at the very center of the part, inside of the part. So maybe it's a critical location, maybe it's a defect location there. So we need to make sure that every location is assessed during the production phase. As I mentioned earlier, here is our technology. We connect to the production line. We start to get data. We analyze it in seconds, so it's real time. We give recommendations about how to improve production process, such as what's the optimum temperature, what is the optimum pressure should be applied to the production line as a setting. So operators can get that insight and apply onto the production machine, or it can run like an autopilot without need of an operator. So this is a video showing our technology working in a Beko refrigerator production facility. Hopefully it will work. Let me try. Could you start the video, please, if it's possible? No? I think there is something wrong. Thank you very much. So this screen shows our recommendations, analysis and recommendations screen. There are heaters in the production process. So each cell is an individual heater, and blue dots showing the heaters that should be tuned in order to prevent defects in the part. So operator gets this insight and applies onto the production line to reduce scraps and improve manufacturing efficiency. So in the refrigerator factory of Beko, we reduce scraps by 50%, we improve overall equipment effectiveness by 20%, and we managed to reduce their plastic consumption costs by more than €2 million every year. We deployed this solution in less than 1 week, and its return on investment is quite high. We deliver solutions in the scope of many supported European Union projects. We are partnering with Siemens, Fraunhofer, Ford, Mercedes-Benz, and we have more than 40 partners in these consortiums, and we are the digital twin technology provider in these consortiums. We provide solutions starting from electric vehicle motors and also defense parts, such as composite parts of an aircraft wing and such. We also in negotiation with Turkish aerospace industries and Aselsan and more. Our market size is huge on defense. For example, digital twin market size on defense is more than 46 billion euros. On the civilian side, it's even higher. It's $260 billion market size. When we check our competitors, we see that Simularch differentiates itself from their competitors by two main aspects. One of them is the plug-and-play connectivity of it, and the other one is physics-informed simulation part of it. So we will be the leader in this market. Yeah, so there are multiple capabilities in our solution, starting from data acquisition from the factories, data analysis, AI model predictions, and at the end of the day, prescriptive digital twins for optimization and virtual tests in the production line. So we are able to deliver all of these capabilities. And according to these capabilities, our business model offers three different tier-based pricing plans and solutions. So our prices is based on licenses per connected machines. Here is our growth strategy and financial targets. Our first goal is to land into factories. Currently, we are operating in civilian side, but our goal is to penetrate into defense factories as well. So our goal is to obtain 500,000 euro ARR at the end of the first day. We are close to that number, to be honest. In the second phase, our goal is to obtain 2 million euro ARR with the help of expansion in these facilities. So to say, increasing the number of connected machines inside the factory. Afterwards, our goal is to dominate the market with the implementation of our solution into different industries and obtain 100 million euro ARR with installation to more than 500 factories worldwide. Our team consists of 4 PhDs and we have very powerful technical team members. In total here you see 13 people. I could not add 4 here, so I simply noted down there. So we have a very powerful team. But as you see here, we need to increase our headcount in sales and marketing and growth and technical support, like a customer service, after the implementation of our solution. Therefore, our goal is to fundraise right now. So far, we work with large enterprises. We continue to do that. We have 2 different entities. One of them is in Turkey, and the other one is in the Silicon Valley, USA. We have investors from there and here, including a top dual user investor in Turkey, which has connections to defense industry presidency in Turkey. We are currently looking for 2 million euros as seed funding to improve our operations and improve customer satisfaction worldwide. Thank you very much. Do you have any questions?
Çok teşekkür ediyoruz katılımlar.
Thank you very much for your participation. We're going to keep you on the stage for a little while. I'd like to invite Mr. General Manager on to the stage now.
Come and have a family photo together. Thank you so much. Aman ayağına dikkat et. Aman.